Let's continue the implementation. So we have constructed card, computer player, deck, game, hand, human player, and suite classes. And let's go from the easiest class to the more complex class. So it's called actually bottom-up approach. We can also do the reverse up to bottom or the top to bottom approach. Both of them are possible. So let's go from bottom to top. So we actually implemented the card almost. So we need to write the compare to. And in the compare to, we will compare two cards and return 1 if the card is bigger than the second card, -1 otherwise. So let's take the next card. Let's say card 2 is actually, we need to cast to the object to the card. And then we need to compare first the ranks. So if the suite is equal, suite equals spades, because spades is actually the most important trump, and the card 2 actually suite equals spades, actually not equal the spades, then actually the we have a better card. And the reverse is if the suite is actually not equal spades, but the card suite equals the spades. So in that case, the second one is important. So otherwise, none of the card suites are spades, or both of them are spades, or both of them are equal. So in that case, we should check if the suite if the suite is not equal the card 2's suite. So in that case, if they are not equal, then the second card do not follow the first card suite. So in that case, we return 1, because you should follow the suite. So if you don't follow the suite, so in that case, the first player will win. So in that case, okay, so we have the first case when the first player's suite is spade, the second player's is not spade, the first player wins. And if the first player's suite is not spades and the second player's suite is spades, the second player wins. Otherwise, both of them are spades or both of them are not spades. In that case, if the suite is not equal to the second card suite, so in that case, we return 1. So in this case, the remaining case is the both suites are equal. And then what should we compare is we should compare actually now the ranks. So in that case, there are these cases. If actually the rank, if it is 1, then it is ace and it is the largest one. So in that case, if the rank is actually larger than the card 2 rank, let's say, let's do also the ace comparison. So if the rank is 1, then actually the second card, without the second card, the first player wins. And otherwise, if the second card's rank is 1, so in that case, we return -1. And then otherwise, if the rank is larger than card 2 rank, we return 1. Otherwise, we return -1. So we actually do not return 0 because we assume that there are no two equal cards. It is impossible. Okay, so that's actually the logic. We may have missed something, but we will see when we will run the code. So other than that, we should also display cards. So in order to display cards, we need a toString method. That toString method should return a string. So let's call this function public. And in that case, what will we do? So if the card, in that case, let's write switch suite, and then case clubs. So you return C plus rank. So if it is hearts, then you return heart plus rank. And if it is diamonds, you return diamond plus ranked. And if it is spades, then you return spades plus rank. And maybe we can do better because the ranks will be 1, 2, 3, 4, 5, and 1 is actually ace, and 11 is jack, etc., etc. So maybe we can do something like this and say, let's say result is empty. And then we can say result is C. So we have a break, and then result is H, and then we have a break, and then result is D, and then we have a break, etc., etc. We continue like that. And what will it help us? So depending on the rank, we will actually case 1. We will say result plus A. So it will be club ace. So heart ace, etc., etc. So then let's give a break. So let's initialize the result. So if the case is 11, so result plus equals jack. And then we have the queen case. And we have the king case. 13. And for 10, they sometimes utilize the T, 10 for T, and then for others, default, we have rank. So then we can return actually the result. So that's actually the toString method, which actually combines the suite, first character, with the rank, and the ranks are except the numbers from 1 to 9. There are special ranks, so therefore we can give it like that. Okay, so we have implemented basically the compare to and the toString methods in the card. Okay, so then let's continue with with what? With the hand. So in the hand, we have the constructor where we have an array list, and then we have the add card where we will add the card hand and a card, and then we remove a card. So in that case, we can remove the object by just utilizing can't remove card. And then another one, we remove the card with the index, which is index of the card. So with the array list, it's easy to add and remove also with the index. Okay, so these are easy. So with hand, maybe we need also the getters. So let's say, let's also display size of the hand, which means return hand size. And we can get card, which returns the card. So in this case, we are not sure if we will need these functions. Let's write these, but other than that, we will see if we need them or not. Okay, so these are specific size and get card functions. Okay, so other than that, we have the hand. Let's close it. So let's come to players. So for the players, this is a little bit tricky. So in that case, we will follow it. So we have the play card, which should be implemented in the human and the computer. We have the player, which sets the name and points, which are okay now. And then we have the calculate points. So then how will we calculate it? So let's go and see the bidding. So the scoring. So then the trick count of each player is compared to their bid. If the player made at least the number of tricks bid, 10 points for each bid trick is awarded. So what will we do? If then the tricks are bigger than the bid, then we have a good point. And which means the points should be added, tricks minus bid, actually bid times 50, bid times 10, excuse me, plus tricks minus bid. So that's actually what is it. And then if the player fails to meet its contract, which says if the tricks is less than the bid, so these are equal. So in that case, the 10 points are subtracted for each bid trick. So in that case, we need to subtract 10 points for each bid. So that's again, then whenever a player makes more tricks than they bid, a single point is for each over trick that is sent back. So in that case, that's actually the scoring. So easy to go. Okay, so other than that, we have the initialize game. In the initialize game, we actually have the new hand, and then we have the tricks equal to 0. So that's actually the thing we do. And then when we need points, we return the get points, and then we need the hand of the player. So in that case, we should return the hand of the player. So in that case, we should implement actually this toString method of the hand. Let's implement it. So public string toString. So in that case, what will we do? We will actually get each card's string and then concatenate them and then return the cards. So in that case, one possibility is to sort the hand with respect to the cards suite. But let's do not do that. That's actually a possibility. But let's do not do now. We can do that actually. But let's do not do that now. So what will we do is we will have an empty string at the beginning, and then and the string will be actually the first cards. So let's get the get the 0 cards to string. So then other than that, we have I equals 1, I less than hand's size, and I plus plus, and then we will actually have a string concatenation by empty, and then we have hand get I to string. So we concatenate every card string together by putting an empty string in between. So the first card's string is put in the result, and then for each card you put the card string next to other. So and at the end you return actually to the result. So then the players actually display hand just returns the hands to string. So that's actually the display hand of the player. So other than that, the player is okay. So let's also close the player. So let's go and continue with the human player. In the human player, we ask the human his or her bit. So in that case, we need a scanner class. Input equals new scanner system.in. And then we ask by system out print line, enter your bit. And then actually the user will enter his or her bit. So let's say the bit equals actually input dot next int. And then we actually return the bit. So the user will enter the bit, and then we return the bit. So in that case, what we can do is we can control the bit. So in that case, while the bit is less than 0 or bit is larger than 13, we can do this again and again. So in that case, if the bit is -1 or if the bit is larger than 13, the user can bid 13. Then it will enter your bit again and again. Okay. Okay, so that's actually the make bit method. So then the play card. So the user will play the card. Actually, first we need again the index of the card to be played. So in that case, we say enter your card index. So the card index should be between what? It should be larger than, or it should be actually not less than 0, or it shouldn't be larger than equal actually the player's hand size. So let's say hand size. So in that case, we should get the enter correct index, let's say. And also we actually need to check the rules. So if actually we need to return the hands get card index. If it is against the rules, then we should not allow actually that card to be played. So in that case, we can do the control here, or we can write a function to control actually if the card is possible to be played or not. Since actually it should be also controlled for the computer, we can actually write the function to check with in the player class actually. So in that case, let's say in the player class, we need to check for the correct play. So let's write then an abstract method in the player, a protected method actually, protected Boolean check card, and the check card will be something like this. We have the card to be played, and we have these parameters in the check card. So then if the check card or not, or check card hand get card index and first player and suite broken and followed suite. So if the check card is true, is not true, if true, it will be here. If the check card is false, so it will enter again as a correct index. So if there is no card, it will directly enter here. So if the index is -1, or if index is larger than hand size, we don't control this check card, because while will be directly true and it will enter the while loop. But if the index is correct, so in that case, the check card is controlled, and in the check card, if it returns false, then this will be true and we will enter again. So, okay, so we need to write the check card. So in the check card, we control if the card is okay or not. So if in that case, so if the player can play anything if it's first player, except the spade. So that's why if it is the first player, then we should control less things. So if it is the first player, we should check if the suite is broken or not. If the suite is broken, then the player can play anything. So in that case, we directly return true. If the suite is not broken, so in that case, if the suite is not broken, what is a possible play? What is an impossible play? If the card suite, so then we can check if the card is trump or not. So then in that case, we should know if it is trump or not. So let's say we need get rank and get suite. So so we didn't have written that. So let's write them. So if we can write is trump. So if is trump, which means if the suite is equals actually spades. So if the card is trump, then if the suite is not broken, you cannot play a trump card. So if it is trump, you return false. Otherwise, you return basically true. So then this can be simplified as not card is trump. But let's make it like this so that we can understand better. So if you come here, in that case, we should follow the suite. So if it is not first player, then we should follow the suite. So in that case, we check what if the card is actually the same suite as the followed suite. So in that case, let's say if the card suite, we need to have the get suite actually. So, or we can write again same suite. Or we can get the suite actually. Return basically suite. So in that case, if the cards get suite equals followed suite, then you follow the card suite. So which means return true. If the card suite is not equal to the followed suite, so in that case, also actually, if the suite is broken, you can and also okay, so if you are not the first player, you must follow the suite, except you don't have that suite. If you don't have that suite, you can actually play anything. So in that case, if the card suite equals to the followed suite, it directly returns true. Other than if the card suite is not followed suite, which means the player should play a card. But in that case, we should check two things. First, if the player has the followed suite or not. If he has the followed suite, it is a wrong play. So then we need to check in the player if the hand has at least a card from that suite. So in that case, we need to write so in the hand a function which checks if the hand has at least a card from that suite. So let's write that function. Boolean contains suite. So suite followed suite, let's say. And then we check every card in our hand. So for integer I equals 0, I less than hand size, I plus plus. So now we check if the hand get I get suite equals followed suite, then you return true. Then you can return here false. So this can be replaced with the enhanced for. So let's also do that with the enhanced for. So we have for each card in the hand, if the card suite equals the followed suite, then you return true. Otherwise, you return false. So then in that case, let's go back to the player. So we need to check if the player has any followed suite. So then in that case, we should check with the hand contains suite, followed suite. If he has that card, and then he or she needs to play that suite. If he or she do not have that suite, then there is the other alternative, which means if the hand contains actually the spades, if the hand contains spades and the card suite is not spades, then it will be also a wrong action. So in that case, we also need to return false. Other than that, we can return true. So let's write the cases one by one. If the player is the first player and the suite is broken, he or she can play any card, basically. So if the player is the first player and the suit is not broken, then the player should not play spades. He or she can play any card other than that. Okay, so that's actually for the first player's issue. So if the player is not the first player, not the first player, and he or she follows the suit, then the play is correct. If the player is not the first player and he or she does not follow the suit, then there are two cases. Either the player, then if he or she has the followed suit, he or she must play that suit. So that's actually a rule. So if he or she has that suit, so if he or she does not also have the suit, so he's not first player and he doesn't follow suit, and if he does not have the follow suit, he or she play spades. Okay, so that's actually the rules. Okay, so that's actually the rules for the check card. So maybe we have missed something, but we will also see that when we check the code. Okay, so let's come back to the HumanPlayer. So if the card is correct, so in that case, if the card is not correct, you enter a correct index, and then other than that, you return get card. Okay, so there can be a very exceptional case. Now I remember. Let's say the suit is not broken, but you only have spades. So in that case, you should play spades. So in that case, we should also add that to the player. So in that case, there is also that case if the user followed, if the hand contains followed suit. So that's also okay. If that contains suit, and in that case, and let's say we can also write in that case the hand, let's say hand okay, we can do something like this. Okay, we can write contains only spades. So for each card, we return false. If the card search equals spades, not spades, so we return false, we return true. So in that case, if you have not spades, you return false. So let's come back. So if the hand contains suit spades, but also you shouldn't have only spades. So in that case, what can we write? So if the hand contains spades, if your hand does not contain spades, you directly return true. If the contains spades, but also if the hand contains only spades, then you return true, else you return false. Okay, so if the player has only spades, but the suit is not broken, the player should play spades. That's very exceptional case, but it occurs sometimes. Okay, so that's for the player's rule. It's get complicated and complicated. So let's continue with the HumanPlayer. So with the HumanPlayer, we play the cards. So that's okay. Let's go to the player. We displayed the hand. We calculate points. We checked the cards. And then in the hand, we have contains suit, contains only spades. And then we have to string. Okay. So we have in the card, we have get suit, we have is trump, etc., etc. So, and then we have, we do not change the seat and rank, therefore we make them final. And we also do not change the hand, let's make them final. And we'd also do not change the name, therefore we can make it final actually. Okay, so in the player's string display hand, we can also write something like this. We have the player name plus, for example, something like this. So the first player's name, and then we have this. So that's actually good. Okay, so we have utilized the name, we have hand, we have card, we have HumanPlayer done, and then let's come here to the deck. So in the deck, we should initialize the deck, we should shuffle the deck, and we should deal the cards. So let's start with the initialization. So we need to have actually 4 type of suites. So I++, and then we have actually, so let's say switch I, so K0, let's say the suite equals what's clubs break. So for each type we have case 1, case 2, case 3. So we have diamonds, we have hearts, and we have spades. And then we have for each card type 13 cards. So let's cover them. So then we can add the cards one by one. So let's initialize first card. Card equals new card. And then we have the suite. And then the card number. So in that case, we can do something like this from 1 to 11. So let's make also this default so that it will not give us any kind of error. Okay, so then we add this to the deck. So deck add card. Okay. So, but we didn't initialize the deck, therefore it gives us the error. Let's also initialize the deck, new array list, and then we have the deck. Okay, so that's actually initialization of the deck. And we need to shuffle also deck. So for that, we actually utilize the collections shuffle, and then we have the deck. We just call the shuffle method of the collections class. We can also write it basically, but let's do it like this for now. And then we will actually deal the cards. So how will we deal the cards basically? So we have a number of cards, and then for each player, we will give cards to each player. So in that case, we need to have actually the players. So when what is a possibility? A possibility is the game then can give the players array to the deck so that it will send the players the cards, or other possibility is to actually, what is another possibility? We can put it in the player. So, but it will be not so good strategy. Okay, or other than that, we can, for example, give a player. So let's say we have a player, and then what will the deck do is it will send the current card to the player. So that's, in that case, we should have a variable which checks which card is sent now. So if we do this only for one player, we should do it, we should give a card index here so that when you call deal, then deal one card, or deal some card, or deal all cards. Let's do like that. So in that case, you should give the players to the function so that it will give the players one by one the cards. So that's actually a design choice. Let's do like that, deal all cards. Okay, so deal all cards. We will deal the cards to the players. And in the player, we also should have add card method, which actually needs to send it to the hand. So, okay, let's also add a method here, public add card. So in that case, we have card, and then we actually add card to the card. So that's actually add card method. And then in the deck, then we will have, we will send cards one by one, or number of cards to the player. The number of cards should be divisible to the players. So what will we do is actually, let's deal the cards one by one without number of cards. So in that case, we can do something like this. So let's say for integer I equals 0, I less than deck size, I plus plus. So in that case, let's also do a player index, which is 0. Then we actually add players add card, players actually player index add card, which card the deck get I. And then we increment the player index. Player index equals player index plus 1, but mod 4. So that it will be circular. So the first player will be 0, then 1, then 2, then etc. And then the players will have all the cards. Okay. So in that case, we can also add it with an enhanced form. Okay, so the players are added all its cards. We also shuffled the deck, and that's actually okay. But when we deal the cards, actually this will be the new game. So therefore, the player should clear his hand. So we can also write, we need also write the clear hand method before dealing the cards. So in that case, we can create a new hand, or let's see what are possibilities. So let's clear the hand here. So void clear hand. So then in that case, and clear. So we need also write a clear method here. Actually, we may not need clear method because the cards will be played one by one. So okay. So we don't need the clear method actually. So that's okay. We have the deck. We dealt all the cards. Hopefully. So we have the deck. We constructed the deck. We shuffled the deck, and then we deal all cards to the players. So almost done. We have cards, we have deck, we have hand, we have human player, we have player, and we have suite. So let's come to game. So in the game, we need to initialize the players. So let's also write that in the beginning. So first we should ask the user which index he or she will be. So human index equals input dot next int. And while human index is less than 0 or human index larger than 3, then you get the human index again. So let us write enter your index. So the index, okay, so that is the case. He or she needs to write between 0 and 3. So it could be from 1 to 4. Let's also write that. 1 to 4 or 0 to 3. So 0 to 3. And then if he or she writes wrong, then we can ask it again here. Enter correct index. Okay, if the user enters a correct index, then we can initialize actually the players. So for integer I equals 0, I less than 4, I plus plus, and if the I equals human index, then players I will be new human player. And we should also ask the name of the player. System out print enter your name, and then we get the name of the player. So input dot next. So then we should initialize with the name, the human player. Other than that, the players I will be new computer player with the name computer what? Computer what? Computer what? Computer I. Actually, computer 1, computer 2, computer 3. So we can actually have another index. So integer j equals 1. And then we initially increment j here. So that's actually something like, so the first computer player will be computer 1, then it will be increased by 1, etc., etc. So the computer players will be players I, player A, etc., etc. And then we have actually the players. So the players are initialized. We also need to initialize the deck. So deck is new deck. So, and then that's all actually. So we get the name, we get the index, we get the correct index, etc., etc. So then we can, for example, display or cards. So in that case, we have the deck, then we can shuffle the deck. And then we can actually deal the cards. So, or we can do that in the play game. So actually in the play hand. So let's do that in the play hand, not here. Okay, shuffle the deck, deal the cards. And then we need to call the bidding stage. And then we have 13 stages to play the turn. So in that case, each time we have a player index. So let's initialize the player index, which will be the first player, or let's say first player. The first player will be 0 in the beginning, but it will be updated by the play turn. So first player equals play turn first player. So that at each stage, it will also return us to the first player. So play end is like that. And then we have the bidding stage. Let's not go over it now. We can write the game over, or we can write the winner of the game. So for this one, we need to check for integer I equals 0, I less than 4, I plus plus. If the player's I points, so the player's points is actually should be protected. So why we can see it actually. We don't see. Okay. So since it's actually, how can we see it? Player get points is larger than 500 or larger than equal 500. If any points, players points larger than 500, we return true. Otherwise, we return false. Okay, so if any player's points is larger than 500, we return true. So winner of the game. So in that case, we again check the player. Let's first put a winner player default null. And then we go over all players. And then we have something like this. And the max points max point should be 500. Because if there is a winner, he or she should have larger than max points. So if the players I get points is larger than max points, we can write it 499. So in that case, winner is players I, and max points equals players I get points. And we return basically winner. Okay, the winner is now. We have the max points 499. If the points is larger than max points, we get the winner, and then the max points is that. So game over. If any player's points is larger than 500, we return true. For the play hand, we have first player, and it's updated. And that's actually almost done. We play the game. So in the play the game, let's finish here.